2, 1. Okay, it says the stream is live. It says we've been live for 7 seconds. 0 dropped frames so far. We are sitting at 10% CPU utilization. Ooh, is that 16? Oh, okay. So I'm not even going to look at the kilobits per second because it's jumping between like 1600 and then 200. But I think we're doing pretty well so far. CrunchyDragon, please feel free to introduce yourself.
Hello, I'm CrunchyDragon. I'm a forum moderator on linustechtips.com, and I like technology.
And I, as you already know, am TopHat Productions 115. I'm a member at the LTT forum and also current owner of the TXP-Network. In this video, we're going to be discussing some current issues. The current thing that we're going to be discussing is the cloud. And it's going to be a multi-video series, a series of tech talks covering the following topics. First, we're going to be covering cloud as the XaaS service architecture. We'll also be bringing up sources as we go along. The next thing that we'll be bringing up will be cloud versus local and or on-premise. Then we'll be talking about the introduction of 4G LTE and 5G. We're leaving out just 4G LTE only because LTE was the actual 4G. If I remember correctly, just regular quote-unquote 4G was actually an enhanced version of 3G, but I might be wrong on that one. Don't quote me. Then from there,
This used to be what I recall.
Yeah.
Let me check that real quick.
Then from there, we'll be talking about privacy and piracy on the internet. So we're going to be talking about those two things. From there, we'll be talking about the crime triangle, as I like to call it, which is crime is most likely to happen in the presence of opportunity, motive, and rationalization, and how the market and we as a community can actually stop giving end users these things. But I'll get into that later because that's going to be kind of one of our later points. Then from there, we're going to get into the introduction of self-hosted solutions and the rise of home lab and home data center solutions. And then from there, our final topic will be whether or not Netflix and Spotify streaming is just a consumer fad, whether or not it's a phase, similar to what teenagers go through in their angsty days. So with that said, we're going to have at least 1, 2, 3, 4, 5, 6. We're going to have at least like 6 to 8 videos going up in the next few weeks. And these will be non-gaming videos that I'll be trying to do in addition to our gaming videos. I'll get into the gaming videos at the end of this video. But the first thing that we're going to talk about today, and I'm going to bring up the Discord PM just briefly, is going to... Okay, is Discord going to let me scroll? Yeah, there we go. We're going to bring up the cloud today, and the cloud necessitates that we talk about the following topics. We must discuss not only the cloud itself, but also what came before the cloud. So first we're going to be talking about servers in general and what servers are. Then from there we're going to talk about, oh, you misspelled the word client. We're going to talk about the client server model. Then from there we're going to talk about traditional services that came before the cloud, primarily the service-oriented architecture. Then from there we're going to, extra spaces everywhere, darn it, what is this, Python? Then from there we're going to talk, no kidding. Then from there we're going to be talking about the introduction of the cloud itself. So that's going to be the itinerary. This right here is going to be the itinerary for today's video, and this is going to be the overarching itinerary for the next few weeks for this up-and-coming Tech Talks schedule. So without further ado, CrunchyDragon, are you ready?
I am ready.
Okay, so let's talk about the first topic of what is a server, because I believe that was where everything started in terms of everything leading up to cloud computing and everything that might even lead away from cloud computing in the future.
Yeah, that makes sense. Servers are kind of big in today's infrastructure as far as networks go.
True, but The thing is, a server is simply a centralized way of accessing resources. So, in that sense, for example, if my computer is acting as a server, as long as multiple users can actually access its resources to actually do a specific task. For example, if I make my workstation a file hosting server, it doesn't exactly have to be that big. It just has to be providing a service for one or more users that can be accessed, especially remotely. And that I think that the while the definition of a server has not changed, our idea of what can serve as a suitable server has changed. Especially seeing that I've seen people who can actually do like home lab with Intel Linux and stuff like that, just low power devices. With the way that technology's been advancing, our idea of what's required to actually make a viable server has been slowly but surely not exactly decreasing, but it's becoming more and more. It's becoming easier to actually be able to host a server for certain applications. What do you think?
Right. That could probably be in part of mostly hardware getting better.
Yeah. So
I
for
mean, you've got these tiny little Intel NUCs that people can use for like hosting 3 or 4 virtual machines at a time.
and also
And
things like Plex and stuff like that too.
right. So you don't necessarily need a ton of compute power for like small servers like Pi-hole. Like you can run a ton of servers on a Raspberry Pi.
Yeah, for like lightweight instances, like almost anything can be a server.
Right.
And in those instances, it's more so an issue of power consumption and efficiency than actual compute power that matters.
Correct. That's why Raspberry Pis are so popular.
So,
Because those things kick out very little heat and consume very little power.
oh wait, you've heard of the Odroid, right?
Yes, I have.
Yeah, the entire single board computer community has just exploded recently. And I have to say, they're probably going to be contributing to the lightweight, the high efficiency server space for home lab users in some time. So
Oh,
far,
I
people
believe
are
it.
some people are sticking to the Raspberry Pi, but I'm thinking that other solutions are going to be coming in soon to actually challenge the Raspberry Pi in a meaningful way.
Hmm. I
So
actually do want to get an Odroid at some point.
I,
So,
I can definitely see why. I mean, they were actually very very interesting to me. If I remember, there's one other called a Rock Chip or something like that that also is kind of in the market. But yeah, there's definitely competition coming, and soon we'll just have like a ton of high efficiency, low power options for low power servers like Discord bots and stuff like that too. Distributed services.
yeah.
Speaking of distributed services, there's one other topic that I completely left out of this: HPC, high performance computing. You've heard of HPC before, right?
I believe I have, yes.
Yeah. I'm gonna go in and just bring up a Tech Target article on this real fast and just read the first paragraph. High performance computing is the use of parallel processing for running advanced application programs efficiently, reliably, and quickly. The term applies especially to systems that function above 1 teraflop, but we're not going to focus on that. The term HPC is occasionally used as a synonym for supercomputing, although technically a supercomputer is a system that performs at or near the currently highest operational rate for computers. Some supercomputers work at more than a petaflop, floating point operations per second. The most common users of HPC systems are scientific researchers, engineers, and academic institutions. Some government agencies, particularly the military, also rely on HPC for complex applications. High-performance systems often use custom-made components in addition to so-called commodity components. As demand for processing power and speed grows, HPC will likely interest businesses of all sizes, particularly for transaction processing and data warehouses. On occasional an occasional techno fiend might use an HPC system to satisfy an exceptional desire for advanced technology. There are other links here, but I feel as though this fits in particularly well because of what we're looking at right now. HPC, to me, is kind of an evolution of the server, whereas a server in traditional sense, especially when looking at it compared to workstations, mainframes, and other traditional ways of distributing services and resources, those were all centralized and usually clustered into one area. With HPC, you could actually have distributed computing and stuff like that, where you could have high performance clusters in different areas, and fault tolerance and stuff like that, and fallback, where you can have one location, working in tandem with another, so that if one location goes down, the next cluster just kicks in and says, I'm here, I'm picking up the slack.
Right.
So I'm going to kind of introduce HPC as kind of a precursor for the cloud somewhat, because HPC has been around before the cloud, and then also we have concepts like task queuing and stuff like that, where you could actually send out tasks to different queues. If I remember correctly, Unicore was one of the ones I was looking into years ago. Distributed computing and data resources. So distributed HPC, yes, I'm going to bring that up. Unicore is a grid computing technology for resources such as supercomputers or cluster systems and information stored in databases. It was developed in 2 projects funded by the German Ministry for Okay, I'm just going to say BMBF to keep it short. In European-funded projects, Unicore evolved into a middleware system used at several supercomputer centers. Distributed computing for supercomputers. Unicore served as a basis in other research projects, and the technology is currently open source under BSD license and available at SourceForge architecture. Unicore consists of 3 layers: a user, server, and target system tier. The user tier is represented by various clients. The primary clients are the Unicore Rich Client graphical user interface based on Eclipse framework, and the Unicore Command line client. The clients use SOAP web services to communicate with the server tier. XML documents are used to transmit platform and site independent descriptions of computational and data-related tasks, resource information, and workflow specifications between the client and the server. The servers are accessible only via the secure socket layer protocol as a single secure entry point to a Unicore site. The gateway accepts and authenticates all requests and forwards them to the target service. A further server, Unicore X, is used to access a particular set of grid resources at the time. Unicore supports many different system architectures and ensures that organization full control ensures okay, I think the word that can be gotten rid of there. Ensures organization full okay, I can see what that means. Ensures said organization full control over its resources. I replaced the word that with said. Unicore X servers may be used to access a supercomputer, a Linux cluster, or a single PC. Unicore X servers create concrete target system specific actions from the XML job description received from the client. Available Unicore services include job submission and job management files, access file transfer, blah, blah, blah. I'm going to skip over that. The point is, Unicore is one of those big examples of clustered high-performance computing.
I suppose you could almost fit folding at home into there.
Yeah, and other things too.
It's a good form of grid computing, I think.
Yeah. So, all in all, we have multiple different architectures that we can analyze as precursors for the cloud, because these all existed before the cloud really started kicking in. I mean, they technically were the cloud, but before it was actually called the cloud or given its own specific, architecture of sorts, these services were king. So, for example, someone like Google is kind of a hybrid of things. This is why I hate iPhones. Siri, shut up. I wasn't talking to you. See, this is why I should have stuck with an Android, because my Android, I could say, okay, Google. See? It didn't respond. There we go. So yeah. Purpose of this video is to pretty much discuss everything that came up to cloud computing and then talk about cloud computing. So let's start with the client-server model. In the client-server model, if I remember correctly, the 2 important things is the client requesting access to resources and services on the server, and then the server that is kind of carrying out those requests. So, for example, if I have a simple file transfer if I have a simple FTP server and a client asks for a file off of that, then from the server determines whether or not the client has the right permissions to even access the file, and if they do, then it sends the file down to them, or if not, it'll give them an error instead saying 401 or something like that, permissions not right, denied, and all that stuff.
Right.
So that's the simple view of things. Then from there we have places like Google, where they have multiple data centers that are distributed, and those data centers can act as fallback and fault tolerance to an extent for each other, so that if one goes down, the user can still get that service without being impacted in a meaningful way that they would be able to determine, and meanwhile IT can jump in there and fix whatever is wrong. And that kind of edges on HPC, but isn't quite the same as HPC from what I remember. If I remember correctly, the way that multiple data centers are teamed up is mostly just considered to be fault tolerance, whereas HPC isn't meant, I guess, it's not supposed to be primarily fault tolerance, but more so distributed computing. Distributed computing does not imply fault tolerance, last I checked.
No, I don't believe fault tolerance is part of distributed computing.
Yeah, distributed computing is simply using multiple, possibly different devices to provide a plethora of different services and resources to the user upon request without it all having to be consolidated inside the same area or in the same machine. So for example, with an HPC cluster, I could have multiple different computers possibly running with different architectures working together to provide specialized services that they each do their best on. So for example, if I have like an ARM server, an x86 server, and a Power 9 server sitting around, well, the Power 9 hypothetically could be good for very heavily threaded workloads because, hey, SMT4, 4 threads per core. x86 is good for general computing tasks that might not be as heavily multi-threaded, but maybe AVX workloads and stuff like that are generally done well on x86. And then from there, ARM can be used for lower power, higher efficiency tasks that require multiple cores that might be better handled on ARM than Power 9, or which might not be handled as well on x86. So in other words, providing a wider portfolio of services without trying to shove it all into one machine, because of the fact that different architectures and hardware have their benefits and cons. So in other words, being able to leverage multiple different types of machines as if they are one machine by putting a task queue on each one, and then from here communicating with them all through that task queue to request services and tasks to be completed, and then from there those tasks and services are distributed amongst the high performance clusters, which then send back the results to the user.
Right.
Correct me if I'm wrong, though.
I believe that's correct.
So with folding at home, I think that's HPC technically, isn't it? As you mentioned.
I believe so, yeah.
What about Boink? BOINC?
Boink, I believe that was also listed under grid computing.
I wonder if anyone's done a HPC distributed computing cluster for artificial neural networks yet.
I'm not sure.
I'm thinking they probably have tried it before, but I'm betting that one of the major issues is with like how sometimes because like they're having consumers like jumping on it. What if one of the major issues is the fact that consumer computers aren't always up 24/7, like they have to install updates and stuff like that?
Right.
Yeah, one of the big issues with distributed computing is that in order for it to be reliable, all of the nodes need to be able to stay up for most of the time at the very least. If you have to like service like certain nodes more often than others, it really just kind of messes with like the reliability and efficiency of your compute cluster.
Right.
Because at that point, that service just might as well not even exist. Let's see.
Wikipedia lists virtual supercomputers under grid networking, or grid computing.
Define grid computing.
Grid computing is the use of widely distributed computer resources to reach a common goal.
So
you think about something like folding at home.
So what is the difference between?
All kind of simulating the way proteins fold in the body. And that helps for disease research.
Grid computing versus HPC. this blog page right here might be of some use to us.
Okay.
Grid, cloud, HPC, what's the diff? High scalability computing, or simply HSC here. Okay, first, it's critical for readers to understand the fundamental difference between scalability and performance. Hold up here. This header right here. We keep mentioning grid and HPC, but I think they might be synonyms.
Interesting, yeah.
No wonder. Okay, that makes sense. So the origins of HPC/grid exist within the academic community, where needs arose to crunch large data sets very early on. Think satellite data, genomics, nuclear physics, etc. Grid effectively has been around since the beginning of the enterprise computing era. Yes, this means that this actually could have been a precursor for the cloud, just as I predicted. When it became easier for academic research institutions to move away from large mainframe-style supercomputers such as Cray and Sequent. Nice. Towards more scale-out models using lots of relatively inexpensive x86 hardware in large clusters. The emphasis here is on relatively. So in other words, it was to decrease relative expenses while also trying to be able to actually still be able to do those high-performance computational tasks. Most x86 clusters today are built out for very high performance and scalability, but with a particular focus on performance of individual components or servers. And the interconnect network, for reasons that I will explain below, price and performance of the overall system is not as important as aggregate throughput of the entire system. Most academic institutions build out a grid to the full budget that they have, attempting to eke out every ounce of performance in each component. This is not the way that cloud pioneers such as Amazon.com and Google build their infrastructures.
Interesting.
So I'm going to include this as a source in the description of the live stream when this is all over.
So down here he talks about cloud versus high scalability, or cloud and high scalability computing, which are kind of the same thing, he says.
Go on and talk about that.
So cloud, or HSC by contrast, focuses on hitting the price performance sweet spot using truly commodity components and buying lots more of them. This means building very large and very scalable systems.
That sounds somewhat similar to what gamers are trying to do nowadays, only it's not exactly commodity. Gamers are looking for that price to performance sweet spot as well, but it's not as much commodity as it is trying to get the best performance per dollar, isn't it?
Yeah, so, and we don't buy many gaming PCs at once.
Yeah, so whereas the cloud requires efficiency, we require higher performance for our dollar.
Right, so I actually wanted to talk a bit about this because I have a buddy that has got like 8 Lenovo ThinkStations.
Ooh.
And he uses those in, I forget which type of cluster he said, but he's got all those all working together, hosting and running like 30 different types of servers and services.
He sounds like he's doing what I'm trying to do right now, only I'm also trying to do it via ESXi, like trying to push everything onto like a single server.
Mm-hmm.
Go on.
Yeah, he's kind of doing that.
Dude. Like, if I remember correctly, so in other words, is he accessing them as if, are they working as one computer and he's just sending tasks over a task queue that's then distributed to the workstations?
I think he is. Let me double check which cluster he's using.
Oh, snap. That's cool.
And how it works. Yeah, he's got a Kubernetes cluster.
Kubernetes cluster? How do you spell that?
Kube. Yeah, I'll send you the wiki page.
Okay. I gotta see this. I like how
Yeah.
Discord has that spoopy, what's it called? The spoopy link warning.
Mm-hmm.
Commonly stylized as K8S, is an open source container orchestration system for automating application deployment, scaling, and management. Nice. So, in other words, this could be used like I wonder how this does compare to Unicore and other older technologies.
Yeah, I'm not sure.
This is probably easier to set up.
That would be my guess, yeah.
One day, I think we could try like testing out like Kubernetes versus Unicore just to see how they handle things. But I would need like multiple computers, and I've been throwing out every computer I have to try to get to one super powerful hybrid server workstation.
Right.
So you'd probably have to do that.
I could try.
Wait, maybe we can contact Hotaru. If Hotaru has like two computers, he could like use like a lightweight tablet or laptop as like a client to like kind of not exactly remote access, but just access the task or command queue for like a hypothetical Kubernetes or Unicore cluster.
Mm-hmm.
All you need is two computers, as long as there's more than one to access.
Right, because if there's just one, it doesn't count as a cluster.
Yeah.
That's just a single computer.
Yeah, that's practically just a traditional server in that case.
Mm-hmm.
So I'll put these, I'll make like a little examples section right here. Okay. So we've talked about the client server model, we've talked about HPC. We now have to talk about service oriented architecture.
Right.
And that's going to be pretty much the last thing that we talk about before we get into the cloud. Because everything here is probably using service-oriented architecture last I checked. Which is going to be different from cloud architecture.
Right.
Because
service-oriented means you can host a website from it. And the website can have files on it that you could also download from it. But you wouldn't be able to use it for like... wouldn't work as well for something like remote gaming PC.
Yeah. Remote compute is one of those things that the cloud does that the service-oriented architecture might not have been as well prepared for, I guess. Before there was cloud computing, there was service-oriented architecture, or SOA. While cloud encompasses implementation and application delivery options, SOA is concerned with the foundation underneath that makes it all possible. The bottom line is, without SOA, it's very difficult to get to the cloud. An elevator pitch definition of service-oriented architecture, I'm going to be calling it SOA for short from now on, would be loosely coupled services with well-defined interfaces. Who dares to call me during a live stream? Someone's getting knocked out. Hello, who is this? Great. You know what really sucks about some of these calls? When they start talking, but then the call just straight up cuts out of nowhere and they hang up.
Sounds like we should get a service-oriented server for that.
Yeah, it's really dumb. They sit there, they have like a real human on the line too this time from what I can tell, and all of a sudden the line cuts out and you hear that click sound that sounds like they hung up.
Mm-hmm.
So why are they calling me if they're just going to hang up 5 seconds later into the call? Man. And people wonder why some just want to do like TDOSing on like telephony servers and stuff like that. Literally ticking off people like me who know what a TDOS is, but I don't want to TDOS anyone because that would be rude and I could get in trouble for it. Even though we have people like this harassing us during important times like live streams.
Mm-hmm.
But anyway, I'm not going to talk about that. We'll talk about TDOSing in another video if you actually want to hear about it. Leave a comment saying TDOS if you want to hear a video or see a video on TDOS as a subject. Otherwise, we're going to get back to this server or service-oriented architecture definition. Would be loosely coupled services with well-defined interfaces that provide business functionality and can be shared or reused across and beyond the enterprise. These services can be discovered through a registry or repository, I'm going to call that repo from now on, or other directory, and can be assembled and disassembled to meet current business process demands. So that was VMware's definition of the service-oriented architecture that came before the cloud.
Okay, so
So I'm just going to pull up that article right now. Oh, I think I already have it pulled up. Nice. So here's the cloud, though. Cloud computing is an internet-based compute... Yeah, okay, seriously? Thank goodness that notifications are silenced when I'm streaming. Cloud computing is an internet-based computing paradigm where shared resources, software, and information are provided to computers and other devices on demand like a public utility. Okay, so I can see how it builds up from SOA now.
mm-hmm.
Here's the rest. As we've seen in various articles and books, SOA is mainly for enterprise, while cloud computing definition suggests it's for internet-based services. So what's common and what's different? In a previous blog, this dude from the VMware blog mentioned that cloud as an architecture pattern, CAA, which can be leveraged in enterprises as... Oh yeah, interesting. Cloud as an architecture can be leveraged in enterprises as well. If we compared SOA and CAA, they look somewhat similar and share some core principles. First, both emphasize the service concept. By definition, a service is performance of work by one for another. Both CAA, or cloud architecture, and SOA, service-oriented architecture, delegate work to other parts of the system, either by the service provider or other business components. So in other words, distribution of tasks. Doesn't that sound somewhat similar to HPC?
Somewhat, yeah.
Might be a difference in geography for all I know. But I could be wrong in that, so don't quote me. With that delegation, people can use the services without worrying about the implementation details and scalability. Oh, I see. Whereas with Unicore, anyone who's managing it has to actually be concerned about that, right?
Right.
Because you can have multiple devices like from different architectures and make some models just coming in out of nowhere. Okay. Most important, services in CAA and SOA can be shared by multiple applications and users, thus optimizing resource utilization. Second, both promote loose coupling. Each architecture demands minimum dependencies among different parts of the system. As a result, any single change in one part of the system has limited impact on the overall system. Now here is the difference. SOA and CAA can differ significantly. Horizontal versus oh, this is going to be interesting. Horizontal versus vertical services. So how are they going to define horizontal and vertical? The services in SOA mainly focus on business. Service-oriented architecture. Each service may represent one aspect of the business. Combined together, these services consist of a business application or solution. In this sense, the services are horizontal. Services in CAA are mainly layered according to typical software stacks. The lower services support the upper services to deliver applications. Therefore, we call them vertical services. And oh, you were saying?
No, I'm just saying that's kind of interesting. I hadn't really noticed that.
Yeah, so that's how this VMware blogger is actually defining it. He's talking about horizontal versus vertical service provisioning. Application versus infrastructure. SOA is for application architecture, whereas cloud computing is for IT delivery.
Okay.
More often than not, you start with a business problem for SOA and then abstract out the services. These services can be reused by other applications. Whereas for cloud computing and IT delivery, the dividing of services is based on the roles in the software stack that is mostly well defined. You don't need a problem before defining cloud services. The services can be easily reused by... Oh, I see. I see where this is going.
Mm-hmm.
So, I'm just going to go on and say this right now. My ESXi project is probably more so on the side of SOA. You know why? Because it started...
orienting it for a certain service?
It literally started with a huge problem of a fragmented computational environment that I have. And the solution was consolidate everything. And the solution had to be rolled from how do I consolidate everything, and I was like, ESXi.
Right.
And also the use of containers and stuff like that.
Mm-hmm. So just get one really high power workstation, just virtualize everything.
Yeah.
For the most part.
So while it will be doing IT delivery, its primary purpose will be application delivery and also solving an issue that was presented.
Gotcha.
And in the end, the author goes on to say that SAO and cloud computing complement each other very well. Nice.
I feel like that would actually be a decent segue into local and or on-premise solutions versus the cloud.
Yeah, but that's going to be our next video, because now we still have to talk about specifics on the cloud, as in the XaaS architecture or X as a service architecture. We have to talk about that because that's where cloud's been going. Infrastructure as an architecture, platform as a service, infrastructure as a service, software as a service, all that stuff. And then once we get through that, then we can talk about cloud versus on-premise. Because on-premise is literally part of the traditional model where you have all these huge mainframes and servers on-premise doing the job for you versus outsourcing it to someone else's cloud.
Right.
But we have to define what a cloud is first. So with that out the way, we're going to pull up the architectures. And once again, TechTarget is here to save the day. TechTarget on point. I'm telling you guys, go to TechTarget. In fact, I'm going to include links to everything in the description. Search cloudcomputing.techtarget.com. CrunchyDragon, feel free to grab that link while you're at it. I'll even send it to you right now.
That works perfect.
Would you mind just giving us the first paragraph where it just says XaaS is a general all the way to the word enterprise?
XaaS, or anything as a service, is a general collective term that refers to the delivery of anything as a service. It recognizes the vast number of products, tools, and technologies that vendors now deliver to users as a service over a network, typically the internet, rather than provide locally or non-site within an enterprise.
Yeah. So now we're transitioning from cloud as building off of a service-oriented architecture to cloud provisioning a service. So what services can it provide? These are just the main big three last I checked.
Mm-hmm.
There are others as well, but oh dang. We're going to be talking about malware as a service too. Okay, so I'm just going to keep it short, and we're only going to talk about we're going to stop at what are the pros and cons of XaaS and just use that as a part 2 to this video, maybe later today if we get the time.
Okay.
So here are the examples of XaaS. There are countless examples of XaaS, but the most common, and in my opinion the top 3, encompass three general cloud computing models: software as a service, platform as a service, and infrastructure as a service. SaaS provides a wide range of software applications, software including Google Apps, Microsoft 365, and Salesforce, to users. PaaS offerings such as Amazon Web Services or AWS, Elastic Beanstalk, that is an interesting name, Heroku, Force.com, Google, and blah blah blah, typically provide pre-configured virtual machines and other resources for application development and testing. Infrastructure as a service allows organizations to deploy and configure virtual machines hosted in a vendor's data center and manage those VMs remotely. IaaS services include Microsoft Azure, Google Cloud Compute, and AWS Elastic Compute Cloud. Already starting to see some of that overlap there. There are many other examples of XaaS. Storage as a service provides application data and backup storage systems in the cloud, while database as a service, or DBAS, provides access to a database platform through the cloud. Public cloud providers like AWS and Azure have DBAS offerings. Malware as a service, or MAAS, uses the public cloud to get organizations... malware as a service uses the public cloud to help organizations guard against common attacks, such as ransomware and distributed denial of service. So why don't they call it MP as in malware protection as a service then? instead of malware as a service. That sounds like something that some bad guy would use at first glance.
Right.
Some of the names used in tech. But anyway, more examples of XaaS include disaster recovery as a service, communications as a service, and network as a service. Okay, this picture is like entirely too small. Search Google for the image. Can they get me like a bigger version of the image that I can link? Yeah, give me all sizes. I want a big version of it. Open link in new tab. Oh, that's LinkedIn. Come on, where's the image? Open image in new tab. That's what I'm looking for right there. That's perfect. We're gonna put that in the description for you guys, so you'll have like a quick guide as to like the top 3. What are the pros and cons of XaaS? You know what? I think we could probably run through these. CrunchyDragon, feel free to run through these, and then we'll talk about our opinions on it.
Alright. Organizations often choose XaaS because the as-a-service model can cut costs and simplify IT deployments. With every additional cloud service, an organization can shed pieces of its in-house IT infrastructure, leading to fewer servers, hard drives, network switches, software deployments, and more. Okay, so it kind of sounds like
they're outsourcing.
XaaS can help all your services and servers and whatnot just take up less physical space.
Yeah. So they're doing less of it on-premise and using services from other places. They're outsourcing to actually try to decrease their IT infrastructure so that they don't have to manage as much, to try to cut costs.
That's a very good way of doing it, actually.
It is. But in cases like Home Lab and stuff like that, it doesn't really make sense because they're already trying to develop the infrastructure so that we are less dependent on external infrastructure. So in other words, people doing Home Lab and Home Data Center will be the provisioners of XaaS, which would be very interesting, I have to say. The Home Lab model completely flips everything on its head to, instead of the client accessing the server, the client becomes the server, which is just awesome.
That is pretty lit.
Yes. But we'll talk about the implications of that later in our 5th, 6th, or 8th video. Less on-premise IT means less physical overhead, such as equipment, space, power, and cooling. This translates to reductions in IT staffing and firefighting, or allows IT staff to focus on more important value-added projects for the business. In addition, using an outside service rather than on-premise technology shifts many capital expenses, that's an accounting term, to operational expenses for the business. So for any of you who have taken Accounting 101 or 102, this should be ringing a bell. Despite their benefits, XaaS offerings sometimes contend with issues of resilience and internet reliability. Oof, this is why Home Lab exists, because sometimes we don't want to deal with network issues. Well, I mean, we do have to deal with network issues, but if we have more control over it, then we can probably fix it faster, right?
Mm-hmm.
But anyway, some enterprises also want more visibility into the service provider's environment and infrastructure so they can better gauge the service health and assume a more proactive role. In addition, a service provider that goes out of business, gets acquired, discontinues a particular service, or alters its future roadmap can have a profound impact on XaaS, which is where, once again, Home Lab and Home Data Center comes in, because we want more control over our stuff, more privacy, and as a result, we actually shift from becoming users of XaaS to provisioners of XaaS, flipping the whole model once again on its head.
Take that, Google.
Well, not exactly. We don't have any private search engines yet. What we need is like cross-domain proxy-based search engines that can literally spider web crawl all the sites that we want to go to on a regular basis, and then provide us results based off of synonyms and stuff like that. So a local Google that isn't sending our information to external, sources.
Or different countries.
Yeah. So imagine pretty much having your own web search engine locally that you can use to crawl multiple websites, like within a certain, a list of whitelisted or acceptable websites.
Mm-hmm.
You pretty much have your own, well, not exactly internet, but your own, what is it called, where you only access like a specific subset of the internet commonly, and then everything else is considered fringe at that point. I'm guessing that to you, like, everything else would become like darknet, where it's unindexed to your search engine, relatively. But anyway, what is the future of XaaS? The combination of cloud computing and ubiquitous high bandwidth global internet access provides a fertile environment for XaaS growth. Some organizations have been tentative to adopt XaaS because of security, compliance, and business governance concerns. I see where this is going. Where's GDPR? Is someone going to mention GDPR? You know what I'm talking about, right?
I think so, yeah.
However, service providers increasingly address these concerns, allowing organizations to bring additional workloads into the cloud. And they have other nice links too. Now, the thing that I was mentioning about... Oh, I gotta make sure that this is on there, right? XaaS. Yep, okay. Deep web searches. Ah, I see. Okay. So that thing that I mentioned about darknets and deep web, when it comes to search engines, everything that is indexable by the search engine is stuff that is likely to be accessed by users, right?
Right.
So, for example, your high-profile websites like Google, Bing, Facebook, Yahoo, Tinder, and all those other high-profile websites that are easily indexed and stuff like that. All that is pretty much the tip of the iceberg for the internet, right?
Right.
Then anything that isn't as easily indexable or isn't indexed at all, what is that stuff called?
We call that spooky and bad.
I like calling that the darknet because, well, that's where your search engine, your flashlight, can't shine, right? If it's not indexable, your search engine can't get to it. And if your web crawler can't get to it, then you won't be able to see what's on there in advance. So you won't be able to search those pages, and as a result... Okay, seriously. The number even comes up as spam. But anyway, the long story short, anything that your search engine can't index is possibly considered part of the darknet because that's just where your proverbial flashlight can't shine, right?
Right, so it's like...
Those websites that are on library intranets that can't be easily indexed, those onion URLs that can't be easily indexed unless you're using like an onion web index. Tor uses Onion, Rifle is another network, IPFS. I don't know if IPFS is indexed yet. CJDNS I think might be indexed, but I'm not sure. But all those things that aren't easily indexable, or where robots.txt just says no FU web crawler, those are the ones that can't be searched. Those are the ones that are kind of below the metaphorical iceberg, the tip of the iceberg.
Right.
So where my idea of the personal search engine kind of falls on its face is, well, if you have your own personal search engine, who is calling me right now? No. If you have your own personal search engine with a whitelist of websites that you want to visit on a regular basis, then guess what happens to the rest of the internet that isn't on your whitelist?
It becomes the dark web.
For your search engine, yes. Which is why having a personal search engine kind of might not work, probably.
Right.
Good thing I nipped that one in the bud so that no one wastes their time on it. But anyway, that is why services like Google exist, because they crawl everything. So with that said, I am going to go on and start bringing this video to a bit of a close. Some of our sources include websites like Quora, but I am going to grab... I'm going to go on and grab this one right here, because this answer was very, very useful. Thank you to Tejas. I'm terrible with names, so I'm not even going to try to pronounce that. Masters in Computer Science. Yes, nice. We're going to link him right here above the quote that I took. Well, actually, that's the quote from VMware, but this quote from Quora, from Tejas, he is the reason why I decided to bring up service-oriented architecture? His answer provided a lot of insight, which kind of affected the direction of this video, so a shout out to him. And for the rest of you guys, you'll be receiving these links in the description of the video. So, CrunchyDragon, I think it's now opinion time.
Alrighty. I'm great with opinions.
So, pretty much the entirety of the evolution towards cloud started from high-performance mainframes and supercomputers, then transitioned from mainframes and supercomputers over to servers and the service-oriented architecture, which then, I think if I remember correctly, HPC came after that. Or did HPC come around the same time as that?
I think it was either around the same time or after.
Yeah, because educational institutions were actually going for HPC and grid computing. So I think it may have been slightly after, but don't quote me on that. So distributed computing, and after that, we had like the rise of cloud, which came like pretty much just years later when we started providing everything as services.
Right.
So the transition is pretty interesting, actually. We went from one centralized high-performance hub to data centers, which are then distributed and more distributed.
Mm-hmm.
We have been distributing our computational workload over large geographical areas and stuff like that, and also going from, if I remember correctly, one single or several similar architectures to, we've gone from homogeneous to heterogeneous computational architecture, in my opinion. And it's even happening on the micro scale if we look at things like Intel's newest possible architecture that might be coming out, where it's combining multiple different types of cores. If we look at ARM, they're also combining multiple different cores that can do different tasks. We have big and little cores, high power cores and low power cores and stuff like that being combined on the same SoC. But I think that our service provisioners kind of started that first. What do you think?
Yeah, I could see that. Right now I'm just trying to look up the new Intel architecture because I actually haven't read about this at all. So
I'm trying to remember what their interconnect's called. Because
Quick
like
Path.
Hmm?
Quick Path Interconnect, I think.
Might
Or
be
QPI.
that. But they actually they're starting to move from a homogeneous architecture to a heterogeneous architecture, which I find very interesting because it seems to have started in the mainframes and servers first, and then from there diverged out into the consumer space, which really gives credence to the idea that anything that happens in the enterprise space is going to slowly trickle down into consumer electronic space at some point.
Mm-hmm.
Which has me wondering, because Intel is actually trying to integrate FPGAs into their stuff. Will we be seeing FPGAs in our own consumer electronics some years down the line?
Yeah, it's kind of interesting.
We'll be seeing like pretty much specific ASICs showing up for different tasks. I mean, like we already have ASICs for AVX 512 and other tasks that aren't quite general.
Bitcoin mining.
You're saying?
Most notably, we have ASICs for Bitcoin mining.
Yeah, but we're probably going to be seeing a lot more of those ASICs being integrated into the CPU.
That's very interesting.
Which gives credence to the idea of AMD's APUs, because I think Cortex was actually doing a video about how the low-end discrete GPU is going to disappear at some point in the future.
Mm-hmm.
Because of the fact that we're integrating all these things onto the CPU die, heterogeneous computational architecture.
Right.
Starts in large scale.
You can kind of get the feeling like eventually you will kind of run out of room to put stuff onto a CPU.
Even with the node shrinks and die shrinks.
Mm-hmm.
Which just means we'll get bigger CPU dies, and heterogeneous architecture will make it so that the entire thing is an SoC with integrated memory.
That could be very interesting.
What if the entire PCB was just a big fat SoC with a screen on it? And everything inside of it was just interconnects. And then the back panel was, like, the rear side was just literally for cooling off the thing. But it was such a low power SoC that your hand could literally just act as the heatsink.
Mm-hmm.
Yeah, I don't see that happening anytime soon, but hey, it was a nice afterthought. Any closing thoughts that you want to give to the viewers before we close out?
I think I'm very interested in seeing where all this, like where all the cloud computing stuff goes, and how everything as a service kind of matures and grows. I'm kind of interested in seeing how that all ends up in the coming years.
My question is, what happens if Home Lab and Home Data Center just takes off? What's going to happen to all these guys providing paid services when Home Lab starts undercutting them in price?
They would have, well, they still have businesses, right?
They would have to downscale a lot, I think.
Businesses still have the limitation of physical space.
Yeah.
And as mentioned earlier, everything as a service makes it easier for businesses to manage everything. Because they just have remote servers, and they just go talk to those. If there's a problem, they just fix it. Like,
true.
So I think there will always be an audience and a consumer base for everything as a service and people who provide such services. But I don't see Home Lab and Home Lab setups taking it out completely. I don't think there's any possible way that can happen.
It'll simply reduce the number of small-time individual consumers accessing those services, making it so that the cloud becomes more enterprise business-oriented, I think.
Mm-hmm.
That might be where it's going. That would be very interesting if cloud just became more enterprise business-focused. And if the main focus, like, on consumers just disappeared.
Yeah, that would be very interesting.
I could actually see that happening.
I think I could see it happening too, but it would take, like...
A really long transition. Like...
Yeah, it would take quite a while.
Yeah. Let's see. How long has this video been going on? We've been live for an entire hour.
Not bad.
With that, I hope that we've provided a decent overview and introduction of the transition from service-oriented architecture and mainframes/servers over into the cloud space. That is our first video, and I hope you guys enjoyed.
We'll see you in the next one.
We will indeed. And in the next one, we'll be talking about the differences between cloud and local on-premise. So, without further ado, I will end this video. I will change the title of it so that it better fits the topic, and we will see you in the next one. For any new viewers out there, please feel free to leave a like if you liked that video. If you didn't, then that dislike button works just as well. And if you want to, please feel free to subscribe. For any existing visitors out there, please make sure to hit that notification bell if you haven't already done so. I really don't like mentioning this, but this is just how YouTube works in order to get notifications of our next and upcoming videos. And with that, I am going to end the video now. This is TopHat Productions,
And this is CrunchyDragon.
signing out.